Hey there, physical science students. This is Miss Ruark. This is Vodcast 5.1a. And the reason there's an A on here is because, well, I kind of lost track of where my fives were. So we'll just put a 1A on this, right? Why not? Okay, not that you care. Let's move on. Okay, so let's just do a quick review before we get into properties of matter on the phases of matter. So we have our solids. Okay, we have our solids here. These solids are going to definitely have a definite shape, which means it keeps its shape and it has a definite volume. Okay, the particles in a solid are actually moving, or at least they're trying to move, so they are vibrating. So particles will vibrate when they move. Because they are bonded together, they can't really get loose, but they can vibrate by trying to get loose. All right, so then on your liquids, here's some liquids. These have a indefinite shape, which means the shape can change. It'll take the shape of its container. Indefinite. It would help if I could spell knit. But it has a definite volume, which means that it won't fill the container of the volume. It will only fill up as much space as it has. That being said, if I was to take a cup of water and I accidentally spill some on the ground, water doesn't all of a sudden gush all over the room and fill the room. It simply fills that small spot where it was at because that's the only volume that I have of it. All right, and then the particles have room to flow or to move. Okay, so they're just kind of moving past each other. And then in our gases, they have an indefinite shape and they also have an indefinite volume because they take the shape of their container and they take the volume of their container. So they're going to completely fill up whatever container you put them in. And the particles they're just all over the place. Let's put fast moving. And they're constantly moving. And particles don't have any particular, they're not like going down the hall and then they see their best friend and they turn and they go to their best friend. No, these gas particles are going and they keep going until they run into something and then they bounce and they go somewhere else. It's kind of like bumper cars without a steering wheel. All right. If any of you know what I'm talking about, bumper cars, you can drive and bump into things, right? So these particles are going fast. They hit a wall, they bounce off, they go somewhere else. They hit something, they bounce off, they go somewhere else. That's what gas particles are doing. Okay, types of changes that we can have. We can have physical changes and we can have chemical changes. Okay, a physical change would be like this egg here that has been sliced. It's been cut. Okay, so physical changes, blank, blank, in blank of substance. I don't know what I was trying to put here. I'll be honest with you, and I just did this morning. No change in the identity of the substance. Okay, so what's going to happen here is it's simply, it's just changing shape. It changes shape, size, or phase. Okay, but it doesn't change the identity. So we can take that egg and cut it and it's still an egg, right? We can take that ice cube and melt it, it's still water, right? Ice is not ice anymore because ice is solid water, but it's still water. All right, a chemical change is when one or more new substances are produced. So it does change identity. An example of this is these screws and nuts and bolts here. They've rusted, which means that the metal that they were made of, there's still some metal under there, but the metal that they were made of isn't the same metal anymore. It's actually changed. It's a new compound. Okay, that leaf, when it undergoes photosynthesis, there's a chemical change happening inside of it that changes it from green to orange and then, of course, to brown and dead, right? And then the fireworks, of course, here you're applying heat and the gases explode and the beautiful colors that you see are from the different chemicals that are being burned in that fire. All right, phase changes. Phase changes, that means from a solid to a liquid, from a liquid to a gas, from a gas to a solid, etc., etc. Phase changes are physical changes. And this should all be reviewed because we've already talked about all this before, right? Yes. Okay, what are the phase changes? We did this in class. Let's do it again. Freezing point is going to be when something changes from a solid to a liquid. What am I doing? No, sorry. It goes from a liquid to a solid. Sorry, guys. All right, so freezing is liquid to solid. Melting is solid to liquid. And guess what? You, I, I don't know what's going on with my pen. It is acting just all sorts of broke up today. All right, and these are exact opposites of each other. So guess what? The freezing point is actually the same temperature as the melting point of a substance because it's going from one phase to the other and back. All right, boiling point is when you're going to change from a liquid to a gas. Condensation point is when you go from a gas to a liquid. All right, we've talked about these. Sublimation would be when it's going from a solid directly to a gas. And then we also talked about the last one. Go ahead and write this down if you don't have it, if you don't remember it. Deposition is when it goes from a gas directly to a solid and does not pass go. All right, I'll review. Okay, so now let's get into properties of substances. So you can have physical properties of a substance and you can have chemical properties of a substance. Physical properties of substances are things that you can observe without changing it. Okay, so an example of that, over here on the side we have a bunch of different examples. If you look at something and you say, oh look, the background is green, that's a physical property of this PowerPoint. That circle is orange, that's a physical property. It's a circle, that's another physical property. So physical property is just something that describes the way something looks, the mass, how heavy it is, the shape of it, okay, what temperature it melts at. These are all physical properties because you're talking about it without changing it. Okay, a chemical property, it describes how the substance will interact with another substance. So its ability to react. Okay, so ability to react talks about a chemical property. And guess what? The ability to not react is also a chemical property. So if something is combustible, if it's flammable, anything that's able is probably going to be a chemical property. All right. Moving on, your turn. So here are a bunch of them up here, and what you need to do is you need to figure out if they're physical properties or chemical properties. So go ahead and pause it and write them down what you think, and then come back and see if you got them right. Okay, physical properties are things that you can say about something by looking at them without testing them or messing with them, right? So if you see color, that's going to be a physical property. Okay, texture, the way something feels, if it's smooth or rough, that's a physical property. Solubility is talking about how something dissolves in water. Now, if it dissolves in water, it's just simply going from a solid to a liquid. So that's going to be a phase change. Guess what? That is a, I can't spell today. That is a physical property. Flammability. Okay, flammability is talking about something burning, and that's going to be a chemical property. Malleability. Okay, you're like, but it has the ability at the end of it. Okay, well, malleable just means that you can flatten it into thin sheets. That's a property of a metal. It is a physical property because it's not changing the metal, it's just changing the way it looks. It's changing the shape. Okay, ability to rust. There you go. Because rusting is changing the composition of it. Mass is just talking about how heavy it is. Corrosive, that means that it's going to corrode or react with oxygen. So that would go over here. Reactivity, definitely a chemical property because if something reacts with something else, that's changing it. Combustibility, that means that it's going to be able to, right? Well, anytime something goes, it's got to be a chemical change. Acidity, it talks about how acidic something is in nature. And that's just talking about whether its pH is high or low. So, put it over here. We have mass on there twice. Let's take that away. Density. Density is a physical property. So hopefully you did well on that. All right, we're going to try another one. Physical and chemical changes. So now, I want you to pause it, test these out on your own, come back and see how you did. All right, tearing is just taking and tearing a piece of paper in half. It's a physical change. Combustion is in the process of fire and oxygen, and you're changing it into something new, so it's going to have to be a chemical change. Melting, solid to liquid, so it's going to be a physical change. Digestion. You do that at lunch, breakfast, whenever you eat. It's changing it. It's changing it chemically. Grinding. It's still the substance, it's just powder form now. Freezing. Phase change. Physical change. Okay, silver tarnishing means that it's oxidizing. It's reacting with the oxygen in the air. So it is actually going to be a chemical change. Okay, breathing. You might not think of it this way, but breathing is a chemical change. Okay, breathing, you breathe in oxygen, you breathe out carbon dioxide. There's an exchange there, and it changes from one form to the other. All right, crushing something. That is a physical change. Burning. That is a chemical change. And decomposing is going to be a chemical change as well. All right, hopefully you did good. Okay, let's move on. Density. All right, so density is a physical property of matter. Okay, and it is a measure of the mass of the substance per given volume of a substance. So what does that mean? Well, that means that density is equal to mass divided by volume. The different units that you could see would be grams per centimeters cubed, grams per milliliter, or kilograms per liter. I typically will see these, but you could see the other one as well. All right, so centimeters cubed is actually an area of volume. Okay, it is the volume of a solid. Okay, and especially a cube. So anytime that you have the volume of a cube, you do length times width times height, right? Length times width times height. And that would give you the volume of a cube. And you use centimeters cubed. Milliliters will be the volume measurement for a liquid. Okay, so make sure that you know the difference between those. Okay, so let's do some examples. What is the density of an object with a mass of 24.78 grams and a volume of 13.47 milliliters? Okay, so we're looking for density. We know that we have analyze it. Here's our volume, and here's our mass. Analyze, right? And we're looking for density. So D is equal to M over V. And here's our nice little equation here. Okay, we're looking for density. So if you use this triangle here, you can cover it up and it tells you need to do mass divided by volume. If you don't use this, you just set it up this way, plug in for the letter that you're looking for, all the letters that you know, and solve for what you don't know. Okay, so we know we're looking for density. Our mass is 24.78 grams. And our volume is 13.47 milliliters. Okay, so now 24.78 divided by 13.47. And the calculator gives us 1.83964 such and such and such and so on. What happens to our units? They do not cancel, so we keep them. Okay, we're going to do all of our math to two numbers after the decimal. So the 9 makes the 3 become a 4, so our answer would be 1.84 grams per milliliter. All right, let's try another one. What is the mass of an object? So we're looking for mass, with a density of 2.48 grams per centimeters cubed and a volume of 6.78 centimeters cubed. Okay, so we're looking for mass, so you can either do it this way and solve for the letter that you're looking for, or you can take this and cover up whatever you're looking for, and we're left with density times volume. So mass is equal to density times volume. It's going to be 2.48 grams per centimeters cubed times 6.78 centimeters cubed. Centimeters cubed are going to cancel. And now we just do the math, 2.48 times 6.78, and we get 16.8144 grams. But we want two numbers after the decimal. The 4 doesn't do anything to the 1, so it's 16.81 grams. All right, we got one more to go. This one we have a rectangular solid that has a length, a width, and a height. Okay, so I'm going to tell you how to do this. To find your volume, you're going to have to do length times width times height. Once you get your volume, then you're going to plug it into the equation density is equal to mass over volume to get your density. Okay, I want you to solve this and bring it back with you to class to next class, and then we will go through the answer to make sure you've got it right. Okay, and I think that's it, so I will see you then.